This problem asks us to find the area of parallelogram using this vector that goes from 1, 1, 1 to 2, minus 1, 0, and the vector from these 2 points. And so essentially these two vectors are they're not attached to each other right now. They're floating around out in space in R3. And so first we need to write the vectors, which means I'm going to pull them back to the origin, making them position vectors. So the first vector is going to be 2 minus 1, negative 1 minus 1, and 0 minus 1. And the second vector is going to be negative 2 minus negative 2, negative 3 minus 3, and 2 minus 4. So those are the two vectors. Now they're position vectors, and so I'm going to, wherever they are in space, however they're pointing, I form the parallelogram using those vectors, and I want the area of that parallelogram. We know that the area is V cross W. And I'll do this using the shortcut method, but you could also do this using the determinant method. In other words, I'm going to cover up these first two and do the cross product here. That's going to be 4 minus 6. That's going to be negative 2. Then I'll cover up the middle one, and I'll do the cross product, negative 2 minus 0. But then remember, you take the opposite of that, so it's going to be negative of negative 2, which is positive 2. Then I cover up the last column here, and I get negative 6 minus 0. And I can quickly check if this is the actual cross product by taking seeing if it's perpendicular to both of these. First one is negative 2, negative 4, plus 6. Yep, that works. That gives me 0. This is 0, negative 12, positive 12. So this is the right cross product. And I remember I need the cross product because the area of this parallelogram is the magnitude of the cross product. So the area I'm looking for is the magnitude of V cross W, and that's going to be the square root of negative 2 squared, positive 2 squared, and negative 6 squared. That's the square root of 44, or if you want to, this is actually 4 times 11, so I can take the square root of 4 out and get 2 square root of 11, but square root of 44 is fine too on this one. So that would be the area. The main thing was recognizing these aren't the vertices of the parallelogram. These form the two vectors, the endpoints of those vectors, and then I place those two vectors together to get the parallelogram.